Hey everyone, thanks for tuning in. We're going to look at balancing chemical equations, and when we balance an equation, we make sure we've got the same number of atoms on both sides. And we do that by changing coefficients. For example, if we had a reaction like this, where we're taking hydrogen and oxygen and we're burning it and creating water, we can see that this is not balanced as written. And the reason it's not balanced as written is that if you count the number of atoms on the left versus the right, you get a different number. So there are two hydrogens on both sides, but there is only two oxygens on one side and one on the other. So it's not balanced in the sense that the left-hand side would weigh more than the right-hand side, so a balance pan wouldn't balance out. And we are only allowed to change coefficients. And what are coefficients? Those are the numbers we write in front of the chemical species. So for instance, I can put a 2 in front of the water there, and what it will do is it will, instead of having just one H2O, we will have a second H2O. So we get two H's and an O from the one molecule, two H's and O from the second. So now we've got four H's and we've got four O's. So we need to reflect that right here. Did I say four O's? I meant two O's. So our O's are now balanced, our oxygens are good, but our hydrogens are no longer balanced, and we can go ahead and fix that by changing a coefficient in front of the H2. That changes the 2 down there to a 4, and at this point everything's hunky-dory. Now notice, although there is one oxygen, and we typically don't write the coefficient 1 in there, it is still there hidden away. So sometimes people forget there's a 1 there, and when they try and add more oxygen, they write a 1 in front of it, thinking there's already a 0 in front of it, but in actual fact there's just 1 there, so don't be fooled. Very good. Here's one for you to try. Can you balance the following chemical equation? So I'm going to start with C2H6, that is ethane, and we're going to burn it, so we're going to react it with oxygen, and when it burns it's going to make carbon dioxide and water. And just go ahead and pause this video and balance this equation, and let's compare notes, and we'll talk about a couple of gotchas. So pause it, have a go, come back. Okay, here we go. So the way we're going to balance this is underneath, we're going to go ahead and keep track of the elements carbon, hydrogen, and oxygen. And if we count up, we have 2 carbons, we have 6 hydrogens, and we've got 2 oxygens on the left. And we've got 1 carbon, 2 hydrogens, and 3 oxygens on the right. And don't be fooled, the oxygens, there's 2 in CO2 and there's 1 in water, so we have to add them both together to get our tally of 3. Now if everything was balanced, we would be done at this point, but it is not balanced, so we get to adjust coefficients. So we need 2 carbons on the right, we can put a 2 there. That will change the number of carbons to 2. It will also change the number of oxygens, so CO2's got 2 oxygens. 2 of them means that now we've got 4, plus don't forget that 1 there, that 5th one over there in water, so we have balanced the C's. Hydrogens are not too bad, we got 6 on the left, we can get 6 on the right by changing that coefficient to a 3, and that also messes up our oxygen count, so now we've got 4 from here, and we got 3 from here, and that makes 7, and so okay, and we can fix that by changing one more coefficient. If we have 7 halves, or if you prefer 3.5 oxygens, then that is going to do the trick. If I can go ahead and write, so 7 halves, right, or that is just 3.5 if you prefer fractions. And so why does that do it? Well, if you take 3.5 times 2, you get 7, or if you prefer 7 over 2 times 2, the 2's cancel and leave you with 7. So at this point here, we've got a balanced equation, right? So we've got 2 carbons, we've got 6 hydrogens, and we've got 7 oxygens, so everything is fine. Are you fine? Now, some people get mad at this point here and they say, oh, that's not fair, you can't use fractions. My chemistry teacher said you may never use fractions, and that is okay. So fractions are fine. You can have 3.5 pizzas to eat or 3.5 hot dogs to eat. And some people will say, well, you can't have 3.5 oxygen molecules. And that is correct. So one interpretation of these numbers in the chemical equation is that these are the number of molecules. We'll see later that they're just the ratios. And so the ratio is totally fine to have a fraction. But if you think these are individual molecules, you're correct. You cannot have fractional numbers of molecules. So how do we fix this? Well, the easiest way is just to clear the fraction by multiplying by 2. So if we double everything, then remember that the C2H6, although we don't write the 1 in there, there is a hidden 1. So there are now 2 C2H6s. There are now 7 oxygens. Remember, oxygen is one of those 7 diatomic elements. There are now 4 carbon dioxides, and there are 6, almost doubled that to 7, but 3 times 2 is 6, water molecules. And so this is an equally well-balanced equation. In fact, all you got to do is just double all these numbers here. You got 4 carbons, 12 hydrogens, 14 oxygens, and 4 and 12 and 14. So that's a 5 that I crossed out, not an 8. So everything is completely fine. Now, you might also say, well, maybe I can double it again, right? And so if you double it again, then it is equally well balanced. So you could change the 2 to a 4, and the 7 to a 14, and the 4 to an 8, and the 6 to a 12, and I'll just put ditto marks, and that is also equally valid. So the question is, what is the balanced equation? And the answer is all 3 of them. But there's a special terminology we use for this one down here. And this one down here is the equation that's been balanced with the lowest whole number coefficient. So there is only one equation that has these values here, and so that's why on an exam we will often say balance this equation and using the lowest set of whole number coefficients, and then what's the number in front of the O2? And if we don't say use the lowest whole number coefficients, then we could say 7 or 14 or 21 or 3.5. Actually, any value would technically be correct. So almost always on an exam we will write lowest whole number coefficients, particularly if it's a multiple choice exam. Hey, thanks for listening. So if you're happy balancing equations, you're welcome to skip this next part. But if you'd like to practice and balance a couple more, let me go ahead and write one out for you. And here's one right here. So KClO3 decomposes and forms KCl plus O2. And go ahead and pause the video and try and balance that using the lowest set of whole number coefficients. And then we can come back together and look through it. Okay, you ready? Okay. All right, so if you've unpaused me, so we're going to go ahead and we're going to count the number of potassiums and the chlorines and the oxygens on the left and do the same on the right. We have 1, 1, 3, and 1, 1, 2. So it looks like we almost won. It's like a slot machine, right? Everything matches up but the last one. So how hard can it be? Now, one problem here, and actually one kind of shortcut you can take, is that you can see for every, if we only use whole numbers, by the way, we can see that molecules of oxygen will give us 2. If we've got 2 molecules of oxygen, we'll have 4 atoms of O. If we've got 3, we'll have 6 atoms. If we have 4, we've got 8 atoms. Whereas over here on the left, if we change the coefficient in front of KClO3, we will have, if we just have one of them, we'll have 3 oxygens. 2 of them would give us 6. 3 of them would give us 9. So you can see that if you've got 3s here and 2s here, the simplest way you're going to come together is if there's 6 oxygens on the left and 6 on the right. So how can we make that happen? Well, if we put a 2 here and we put a 3 here, we can get 6 oxygens on each side. So now they match up perfectly. This kind of reminds me of adding or subtracting fractions, where you have to get the lowest common denominator in order to just add the numerators together. What does this do with the other things? We've got 2 potassiums and we've got 2 chlorines, and on the right hand side we've got the same, 1 potassium and 1 chlorine, so we can balance that by placing a 2 in front of there, and now everything matches up. So if you got that, pat yourself on the back, virtually or really, and then we'll move on and try something completely different. Thanks for listening.